Hi, my name is NAJIHAH binti YUSRI. I'm from JCDCS 11038.
Hi, my name is YAHYA from JCDCS 3A.
Hello, I'm UZMA binti AZMI from JCDCS 11038.
Okay, first of all, I will tell you about the introduction. Mathematical logic is a subfield of mathematics that use formal systems to study reasoning and the principles of truth. It provides the foundation for modern mathematics, computer science, and theoretical linguistics. Here are some of the fundamentals of logic that we will learn today. 1. Statement and logical connective. 2. Conditional and biconditional statements. 3. Truth table. 4. Switching network. 5. Arguments. 6. Rule of inference. And last but not least, 7. Logical equivalence. For the first topic that I'm going to explain is about statements and logical connective. Statement is a declarative sentence that is either true or false. It can be represented by a variable, for example, x, y, pq, and others. The variables that represent the statement are called propositional variables. The true value of statement is true if it is a true proposition, false if it is a false proposition. Next, a few primary statements can be combined to form a single compound statement. A compound statement is a new statement formed by existing statement and logical operator which is connective. We will learn 5 connective. First, negation, which is not in the statement. Conjunction, which is and or but. Third, disjunction, which is or. Implication, we use if then. And biconditional, we use if and only if. And those are their symbol. So let's look for this example. So we can determine whether the sentences are statements or not. If it is a statement, we can determine its true value. Sentence number 1. What is your name? We can see this sentence is not a statement because the sentence is a question sentence, which is we cannot say or know the true value, either true or false. Number 2, the sentence is candy is sweet, which is this is a statement because we can know the true value of the sentence. Question number 3, the sentence do your task perfectly. This is also not a statement because the sentence is a command sentence. And last but not least, number 4, which is there is no air. This is also a statement because we can know the true value from the sentence. Okay, now let's look for another example so we can learn more about the statement and logical connective. Here's the question. Let variable p to represent the statement Belle is kind and variable q represent the statement Belle is naive. Construct the proposition symbol to represent the following statement. Okay, number 1. Belle is kind but naive. As you can see, this sentence has 2 statements, which is when it combines, it becomes the compound statement. The first statement is P, which is Belle is kind, and Q, Belle is naive. Do you remember a compound statement? A compound statement is a new statement that formed by existing statement, which is P and Q statement, and they combine by using logical operators or connective. And as you can see, they use but to form a compound statement between statement P and statement Q. So, the answer to construct the proposition symbol for the first question is P, because the first sentence is Bell is kind, which is represent P statement. Then, write the conjunction symbol, which is a letter P but upside down. And lastly, Q, because the last sentence is naive, which represent the statement Q. Question 2. Either Belle is naive or she is not naive but kind. In this sentence, you can see they use three logical operators, which is or, disjunction, not, negation, and but, conjunction. So the answer for this question is Q, symbol for disjunction, left parenthesis, and then not Q, or P, and then close it with right parenthesis. Then for the question 3, if Belle is not kind, then she is not naive. In this sentence, they use implication, which is if then, and negation, which is not. So the answer is not B, if then, not Q. Okay, let's go for the second topic, conditional and biconditional statement. What is conditional? Conditional is if P and Q are propositions, then P implies Q is a conditional statement or implication, which means conditional and implication is the same thing. P is the hypothesis and Q is the conclusion. The following show the different ways of expressing P implies Q. There is so many, so let's go one by one. A, if P then Q. B, if P Q. C, P implies Q. D, P only if Q. P is sufficient condition for Q. Q, if P Q when P Q whenever P Q follows from P, and Q is necessary condition for P. So if you find this sample sentence in the question, you must know this sentence is a implication or condition, which is P implies Q. Moreover, three new conditional statements are formed by making changes in the original conditional statement, which is 1. Inverse, 2. Converse, and 3. Contrapositive. The table shows which is how the inverse, converse, and contrapositive is changed by the original. The second one, biconditional, which is if P and Q are proposition, which is same with the conditional or implication, but the biconditional proposition is P if and only if Q. It also has many ways of read, which is 1. P if and only if Q. B, P if Q. C, P is necessary and sufficient for Q. D, if P then Q, and conversely. And E, P implies Q, vice versa. So don't get confused between implication and biconditional. You must know the difference between the conditional and biconditional so you can know which one it is. For the next topic, which is truth table, I'm gonna pass it to my friend, which is Juma. Hi Juma.
Thank you, KAISAH. So now I'll be explaining about truth table. Truth table used to evaluate statement. It determines the validity of the truth of a compound statement. When constructing a truth table, all possible assignments of true and false for each primary statement must be considered. Each statement can be either true or false in the truth table. So, to find its possibilities, we can make it like this. 2 to the power of n equals to total possibilities, where n will be the total primary statement. For example, we have 3 total primary statements of A, B, and C. So, 2 to the power of 3 equals to 8. We will have 8 total possibilities of true and false. There are 5 logical, connective, and truth tables. which is negation, conjunction, disjunction, implication, and biconditional. I will explain to you guys about all of these 5 logical connective. So, we have the basic setup of P and Q. When we are using negation, we will do the opposite of the original statement. As you guys can see from the table, we have P as true in the original statement, and when we not P, we will get false. The same for the others. If the original statement is true, then it will become false. If the original statement is false, then it will become true. Next, we have conjunction. Conjunction is used to connect two statements using the word and. You can read it as P and Q. To find the logic value of conjunction, both of the statements must be true. Other than that, it will become false. Third, we have disjunction. Disjunction is used to connect two statements using the word or. We can read it as P or Q. To find its logic values, there should at least have one true value in the statement. It will become false only if both of the statement is false. Other than that, it will become true. Next, we have implication. Implication is the conclusion of the statements. The logic values will be false only if the first statement is true and the second statement is false. And the last one, we have biconditional. This one is the easiest to remember. If both of the statement is the same values, then it will become true. So as you guys can see from the table, we have the first possibilities as both true. So the logic values is true. And the last possibilities where both of it is false, then it will also become true. Other than that, we will get false. When the statement is true for all possible value, it's called tautology. When the statement is false for all possible value, it's called contradiction or absurdity. When the statement is either true or false depending on the truth value, it's called contingency. Next, we have logical equivalence for truth table. Logical equivalence is the condition where two logical statements produce the same truth value. The relationship translates verbally as if and only if. It's symbolized by double arrow or triple lines. As you guys can see for the example question from the slides, we have to determine whether the statements are logically equivalent or not. So, for the first expression, we got the logic results of false, 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 true. And for the second expression, we also got false, 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 true. So, these both statements are equivalent. Other than using truth table, we can prove that two statements are logically equivalent by using law of logic. There's actually 12 laws, but the most common people are using only 10. We have identity, domination, idempotent, double negation, commutative, associative, distributive, De Morgan's, absorption, and negation laws. The other two is definition of implication, and definition of biconditional. Other than using these laws, we can also use the three new conditional statements. We have converse, contrapositive, and inverse. Now I'm going to explain about switching network. Switching network or circuit can be divided into two types, which are serial and parallel. The logical expression can be used to represent the network. The connector N is used for serial network. The connector OR is used for parallel network. For serial network, the circuit will work in one line. As for the parallel network, there will be more than one lines in one circuit. This will be the last part of me explaining about a subtopic before I give the speaker to someone else. So we have arguments. An argument is a collection of statements with a set of two or more sentences or beliefs. One of the sentences or beliefs is the conclusion. The rest are premises. As you guys can see from the right, we have a structure of an argument where on the upper side we have a list of premises in the statements, and on the bottom we have conclusion. A conclusion can usually be found on the last sentences of a statement. An argument is valid if the conjunction of its premises logically implies its conclusion. In other words, if the truth table of conclusion is a tautology, then the argument is valid. Remember what I said in the previous slides about truth table? A tautology is when all the possible values is true. So now I'll give the speaker to NAJIHAH. NAJIHAH, it's your time to shine now.
Thank you to UZMA. Hi and Assalamualaikum. I am NAJIHAH and I will take over for the last part. So, I will continue explain about the rules of inference. What is rules of inference? Rules of inference is another way than the truth table that we use to check the validity of an argument. Rules of inference also the basic tools for establishing the truth statement. So, as you guys can see on the slide, here is the list of rules of inference that we learned from this topic. Overall, we have 12, and today I will share with you guys one by one. The first one is modus ponens. The second one, we have modus tollens. The third is syllogism. Fourth, disjunctive syllogism. For the fifth rules, we have addition. Then we have simplification and conjunction. Also, contradiction and conditional proof. Then we have proof by case, constructive dilemma, and the last one, destructive dilemma. For the example, we have a statement which is web crawlers visit web page. If web crawlers visit web page, then web crawlers will add information into search engine index. Search engine algorithm will analyze index relevant, or search engine cannot find any relevant queries. If the search engine cannot find any relevant queries, then web crawlers did not add information into search engine index. Therefore, search engine algorithm analyze index relevant for queries. From this question, we will using arguments and rules of inference to prove this statement is valid or not. By this statement, we can place the variable by P, web crawlers visit web page, Q, web crawlers will add information into the search engine index, R, search engine algorithm will analyze index relevant for queries, and S, search engine cannot find any relevant queries. And then we can have the premise. For example, premise 1, we have P, which is web crawlers will visit web page. For premise 2, if web crawlers visit web page, then web crawlers will add information into search engine index will be P implies to Q. Premise 3, R or S, which is search engine algorithm will analyze index relevant, or search engine cannot find any relevant queries. And the last premise we have as implies negation Q, which is if the search engine cannot find any relevant queries, then web queries cannot add any information into search engine index. For the conclusion, we have search engine algorithm analyze index relevant for queries. Symbolically, it will be R. So, from this argument, we can construct truth table and rules of inference to check whether it's valid or not. The argument will valid if the truth table of the conclusion is a tautology by cat all true. Alright, this is our truth table. Since we have 4 variables, which is P, Q, R, and S, we will have 60 possibilities because we use the formula 2 power of 4. For the fifth column, we have negation Q. We will combine all the statements together until for the last column, we represent the conclusion which is R, and we will get the true. Since the final column we get all true, that means our argument is valid. Then, this part I will show you how to solution the question using the rules of inference. Since we have 4 premises, so the first step we use modus ponens, where we combine premise 1 with premise 2 and we will get Q. Then we will combine premise 4 and premise 5 and get the negation S as the answer by using modus tollens. And for the last step, we use disjunctive syllogism to get R. So, from this slide, we can conclude that fundamentals of logic holds an important role in shaping how people think, communicate, and act in their everyday lives. By understanding and implementing logical principles in a real-life situation, individuals can approach challenges systematically and make reasonable judgment. That's all from me. Thank you.